Hi everyone, my name is Jordan Swanson and my research is focused on material degradation in art conservation, specifically focusing on the Elgin Marbles case study. Conservation is specifically important because it utilizes the best knowledge available at the time to preserve art. Proper conservation ensures that art can be appreciated and provide historical context for generations to come. Knowledge and technology is always expanding linearly with better ways to preserve our art, and the Elgin Marble case study, given its historical and cultural significance, enlightens us to the importance of advancing conservation methods over the course of time to best preserve the art. A little bit about me is that I am a double major in chemistry and art history at the University of Hartford. This makes conservation a particularly interesting area to me because it does combine both art and science. Objectives in this talk are to cover the state of the marbles, how they arrived in Britain after Lord Elgin transported them there, and what the state would be that the British Museum received them in. How conservation treatments performed at the British Museum affected the marbles based on the environments that they were exposed to, and how the conservation treatments affected them overall. Adjustments that could be made to the treatments to better preserve the stone from knowledge we know now, as knowledge is ever expanding, and what's currently happening with the marbles at the British Museum in regard to what conservation and what analyses are currently being performed on them. The Elgin marbles were originally located at the Parthenon in Athens, Greece. Lord Elgin and his crew collected these marbles in 1801 through 1804. They took the sculptures either off the Parthenon structure itself or removed them from the surrounding site via unburying them. In total, they took 247 feet of Ionic frieze, 14 metopes, and 17 pediment figures from the site. They transported the marbles to England by boat. There was the case of one shipwreck, but everything from that shipwreck was recovered over the course of several years. Once everything made it to England, it was kept in cases in the Privy Gardens Whitehall House. And when Lord Elgin fell into financial hardship and was no longer able to care for the marbles, the British government bought them for £35,000 in 1816, and from that point they were relocated to the British Museum. The Parthenon was constructed out of Pentelic marble, which is a white, fine-grained marble. It contains inclusions or veins of quartz, iron oxide, graphite, mica, or pyrite. It is primarily composed of calcium carbonate, making it a soft stone. It also has a low pH, making it acidic, and it's porous, so any water or oil-based liquids that come into contact with the stone surface will get absorbed into it. It's important to note that when the marbles first arrived in Britain, they would have had what is known as an epidermis layer. So this is an orange-brown layer and a beige layer that would be approximately 70 micrometers thick. The epidermis contains phosphorus, aluminosilicates, sulfur, calcium, chloride, and sodium. It's important to note that because the epidermis contains sulfur, it wouldn't interact with pollution because pollution also contains sulfuric elements. The function of this layer is to preserve original finishing marks such as ancient tool traces, detail, and surface texture. Because of these finishing marks it preserves, it's used to authenticate surfaces through conservation analysis. When it is removed, it promotes erosion and sugaring, which is forms of stone degradation. Now here in these images, you can see this photograph was taken in 1910. It has darker portions that are the epidermis versus this 1999 photograph after the cleaning has occurred. The initial cleaning of the Elgin marbles occurred in 1937 to 1938, and the epidermis layer, in addition to a secondary layer of marble, was removed during this overcleaning by the use of copper tools, including 7 scrapers, a chisel, and piece of carborundum stone. Approximately 2.5 millimeters of surface was removed in total, unevenly across the surface of the sculptures, and potentially an acid cleaning solution was used in addition to the scraping of these marbles. This was done to obtain a pure white look to the classical sculptures. London's pollution went unchecked until acts of 1956 and 1968 regulating the levels of pollution that could be present in the city. The gallery that the marbles were housed in was directly accessible to exterior air when windows were opened during hot and humid periods. This directly exposed the sculptures to London smog from 1939 to 1962, leading them to accumulate dirt and soot over the years. After the initial cleaning that took place in 1937 to 1938, additional conservation methods were performed to remove some of the dirt and soot that had accumulated from exposure to pollution. There were frequent washings of the piece using Fuller's earth, which are clay packs to remove the dirt and soot, combined with alkaline soap in addition to these clay packs. Dirt removal processes varied based on the kind of dirt that was being removed. So coarse dirt would have been removed with water and a soft cloth or sponge. Finer dirt would have been scrubbed with fine powder and water, but this often led to the dirt getting further into the stone rather than being removed. There was also the use of carbonated corrosive alkalis to loosen the dirt, but this was replaced with frequent washings of sodium carbonate and water. In the 1970s, the sepiolite poultice method was introduced. In this image, you can see the left figure has had the sepiolite method performed on it to remove that dirt and soot, and the right is all of the dirt and soot that has been accumulated from exposure to that pollution. This method does not use any soap. First, the surface is degreased with an organic solvent or paint remover. Nitromers was a specific paint remover that was used. This degreaser is washed off with sponge and distilled water, and then the sepiolite poultice is applied to hold the water to the surface for a period of 24 hours. The sepiolite doesn't interact with the marble itself, it's just there to hold that water in place so it can remove the dirt. This is all washed with distilled water after that 24 hours takes place, and then it's left to dry for several days before being treated with polyethylene glycol. Annual alkaline washes also occurred where semi-alkaline solution soft soap and ammonia and water was used to wash the sculptures, and that was rinsed with fresh water. Several plaster molding processes also occurred where soap would have been applied all over the surface so that the plaster wouldn't stick. This was followed by the plaster application, and once the mold was complete, the plaster would be removed with soap or soap lyes, which is alkaline residue, or strong acid. A main issue with previous conservation would have been the irreversible damage done in 1937 to 1938 by that overcleaning. The copper tools and carborundum removed a significant layer of the surface unevenly. It also removed the original state that the marbles arrived to Britain in. The removal of the epidermis removed that protective layer that would have benefited against the exposure to the heavily polluted London atmosphere. So now there's direct access for the pollution to the stone. The overcleaning not only damaged the marbles at the time, but also made them susceptible to future damage. And then conservation treatments down the line involved frequent washings. These washings may have degraded the stone based on what type of water they were performed with. So if it was deionized water, they may have taken away from the stone, versus hard water may have deposited unwanted minerals onto the stone. The sepiolite method was very effective in removing dirt and soot caused by exposure to pollutants, but that initial degreasing step would have also removed pigments that we are finding in current analyses that the marbles would have been painted with. When the marbles first arrived at the British Museum, there was no maintenance of a consistent environment. This could have been fixed through the installation of an air conditioning unit. This system would have removed dust, sulfur dioxide, and gas from exterior pollution, and keeping the pollutants out would have been heavily beneficial to the state of the marbles. Maintaining a constant pressure would have also been done by armor-plated glass doors. These installations were done later, but by this point, several conservation treatments had to be done to remove the pollution damage to the marbles. When the marbles also first arrived at the museum, rather than trying to achieve that ideal white to the sculptures, they should have been focused on preserving the state that they actually arrived in rather than changing it. Any chemical cleaning that were performed should have been tested on small portions of the marble before being applied to entire surfaces. And then any treatments should have also used distilled water rather than DI or other sourced water so that it did not take away from the stone. Cleanings should have been performed after dusting occurred so that dust and dirt that could have been on the sculptures didn't interact with the chemical treatments. And the sculptures that were submerged underwater in the ocean for several years should have been treated differently than the other sculptures to ensure that there were no salt deposits or other components degrading the works. Current analyses are working to find missing details on the sculptures that could not have been observed during previous exhibition. They're focusing on more detailed elements opposed to the overall state of the marbles. This includes how the marbles were made, what is present on the surface, and comparing the past state of the marbles to the present state of what they look like today. They're identifying the tools used to create the sculptures through analyzing marks still present on the surface. Some of these may have been removed during past conservation, specifically that scraping of the marbles that occurred, but some do still remain today. Pigments have been identified on the surface through the use of visible infrared fluorescence, which can detect very small traces of pigments. Again, some of those may have been removed, especially during that sepia light method at the initial degreasing, but because it's able to detect such small amounts, we can still see what was present on the sculptures. There's also been mold comparisons to present sculptures via 3D scans. So what you see in this image here is the darker portion is what would have been in the Elgin cast, which took place in Athens prior to the sculptures being moved, and then the thermal green, red, yellow that you see is what the sculpture actually looks like at the British Museum today. So this technology overlays the two images and lets us see what damage has occurred and what portions are missing in the sculptures today. And it also provides a whole image of what the sculptures actually look like. And while there haven't been any major conservation done to the marbles today, there has been gentle removal of dust and dirt that has accumulated before these analyses are performed. X-ray diffraction, X-ray fluorescence, Fourier transform infrared spectroscopy, and Raman spectroscopy are all current analytic instrumentation available to analyze chemical composition. This would be useful in the case of the Elgin marbles because we'd be able to see the chemical composition of what they look like in regard to contaminants that would be currently in the stone, along with what could currently be degrading the stone, and this could influence future conservation methods performed on the marbles. It would also be interesting to see what the chemical composition of these pentelic marbles look like that have been exposed to different conditions and conservation treatments versus pure pentelic marble from Greece, in addition to the comparison of what the marbles from the Parthenon look like that have been currently housed in the Acropolis Museum in Greece, because there is a whole debate about where the marbles actually belong. And it would be interesting to see which marbles have aged better, which have degraded less in that regard. And then optical microscopy is an interesting method that would allow us to look at the material surface magnified. The surface has been through a lot, so there may be certain elements that are not visible to the human eye, but would be visible to the instrumentation, and we could analyze the surface through those means. So conservation is specifically important in this case because it has influenced the state of the marbles regarding degradation and pollution impact on the stone. As new scientific knowledge is gathered, more beneficial choices can be made to preserve the material against degradation. The methods of conserving these marbles has evolved over the course of the years. We now know past conservation wasn't overcleaning, and now we can work on better analyzing and taking care of these marbles so that they last for future generations to come. And what we've learned from this case specifically is not only how to better conserve marble as a whole, but also how the environment that these sculptures are placed in impacts it and how we treat based on that impact. Direct exposure to pollutants is very harmful to the stone, and removing a key layer, that epidermis, also escalates damage done to the stone via the environment. These are all of my image sources. The British Museum was particularly useful in finding imagery for the sculptures. And here are the rest of my sources. Thank you all for listening and joining me here today. I hope you learned something about the Elgin marbles and also the importance of conservation.